Hello, welcome to Taxonomy Online Mathematics. In this video, we are going to continue with set and operations on set, but we are taking the aspect of what? Venn diagram. Now, when we talk of Venn diagram, we are only referring to the relationship, or we use this as a diagram to show the relationship between subset and each corresponding universal set. So these two terms, universal set and a subset. And fast forward, as we go forward, we will add what we call the complement. We have already dealt with the definitions of universal set, subset, and the complement of a set in the previous video. Check it out. So when we want to represent, it's a diagrammatic representation whereby we use circle to represent the subset and a rectangle representing our universal set. So per pictorial, where you represent our universal set, these are the two subsets we are referring to. The subset is just smaller set that can be formed from the universal set. So if I label this A and label this B, I can say that the set A and B are subsets of the set universal set, that is the set U. Meaning all the elements of A and B can be seen in what? The universal set. Good. So this brings us to various regions. So we can stand on this and say we can describe the regions or the parts that this has been developed into. So if you want to describe the regions. Now we know that we have cardinal number of sets, that is using the letter N before writing the set. If I write this, I'm referring to the number of universal sets, the element of what? The universal set. So now if you want to describe, you can see that this region is different from this, and as well different from this. So I can have this to be region 1 as is the overlap, region 2, region 3, and region 4. The 4 here stands for the empty space outside the circle. Now, if you want to describe the set or describe the regions, I can say that A is having a region of what? 1 and 2. If I want to claim the region of B, I'll be referring to A as 1 and 2. Likewise, if I want to find that of B, claiming the set for A, I'll also be having 1 and 3. So if I want to represent 1 as in A intersection B, the region that belongs to A intersection B, that is the element that will be common to both A and B. Which of the regions do you think we can find that? So if you want to do that by shading, I'm going to shade region 1. I'll be shading this region. So this is the region belonging to A intersection B, where both elements are common. Imagine we want to shade the region for A union B, as in putting the set A and B together. Which of the regions do you think will belong to both A and B? I can see you are thinking of 2, 1, 3. These are the regions that belong to. So in shading the region, so the region that belongs to both A and B will be this. And I'm sure in this, you can also tell that the region that is not shaded will be outside A and B. Therefore, it will be the complement. We know a complement of a set is the element of the set that are in a universal set but are not found in that given set. So as we are saying A union B is the shaded region, we can also take the unshaded region to be A union B complement, the region outside their union. All right. Now, if I want to find, let's say, A complement, I want to find the region belonging to A complement. Let me still draw my diagram. We are looking for A complement, meaning the region outside A, elements in the universal set that are not in the region of A. We know that this region 2 and 1 belong to A. So this is the A element. This is the element that belongs to A. Outside A will be which region? I believe it will be region 3 and region what? 4. So in that case, the region I'll be shading that will be the complement of the set what? A. The part that is not in A but in the universal set. So this will be the shaded region for A complement, where we are having this to be for A. Then outside the A will give you that portion. B complement, the region that is outside B, elements that will belong to the universal set but are not in the region B. Okay, you can also see that if you cover the set 1 and 3, the regions that are not in B will be region 2, region 4. So right away, region 2, region 4 will be shaded. So these regions represent, don't forget this is not shaded, this is a complete circle. So region 1 and 2 is the region belonging to B. Region 2 and 4 is the complement of B. Now, what if we also move to number 5 to say that we want to find the region belonging to A intersection B complement. The region A intersection B complement. Where do we have A and B complement intersecting? Alright, you can see that we are having this region as B complement. Where does it meet the region of A? Where does it meet the region of A? You can see the region of A is 2 and 1. This is 1 and 2. But the shading part which is belonging to the B complement is intersecting or overlapping only at the region what? 2. Even though we have region 4. But A is not in region 4. A is in region 1 and 2. The overlap of the B complement and A will be in the region 2 only. So if I'm looking for the region A intersection, if I'm looking for A intersection B complement, then that region will be only, so we call this A only A, not A. A is a region of 1 and 2, but the region that belongs to A without any overlap, without intersection, will be the region 2. That is the area that belongs to only A, no other intersection or overlapping. If we were to use different colors to represent the intersection, the subset, you will see that this region will have only one color. There will be no mixing up of color. That is A intersection B complement. better still A only. So that simply also means that if we take number 6 to be A complement intersection B, A complement intersection B, don't forget A complement is the opposite of this, whereby we are going to find the region outside A, the circle A. The region outside A will intersect the region B at the region 3. So if I want to represent that, so this will be the region, which will also mean what? B only. I believe you are following the concept. That will be the region for B only, meaning the region that is intersecting with A complement, and that will give us region 3 if we are using the regions description. All right, now moving to number 7, let's see. We have A union B or complement. We know the complement of a set is elements in the universal set that are not in that particular set. So in this case, A union B. Okay, let's take the A union first. Let's see what will be the union of A and B. Putting A and B together, I believe it will involve region 1, 2, 3. So if I'm looking for A union B, putting the set A and B together, that is going to be region 2 is involved, region 1 is involved, then region 3 is involved, except region 4. So this region is what we are going to say that this is our A union B. A union B. So A union B is equals to what? The shaded portion. Now, A union B is the shaded portion. The part that is not in A is the outside. So the region 4, the outside, is going to be A union B or what? Complement, which is what? The unshaded part become the A union B complement. The complement is the element outside the union of A and B. So if I want to use the unshaded part, I'll be referring to that as what? The region outside the combination of A and B, the union of A and B. So that region become our A union B complement. All right. Let's take. We've already found the complement of A, complement of B. You know, complement of A is going to be region 4 and 3. Complement of B is going to be region 2 and 4. You see that I mentioned 4. Let's say if I want to find A complement, which are the regions covering the A, is going to be region 3 and what? 4. If I want to find B complement covering B, I'll be having region what? 2 and 4. So which of the regions intersect, overlap? This is the region that overlap. So if I'm looking for intersection of A complement and B complement, that will be the region that is 4, the unshaded region, which is here. So this will also be given. So the region that we have as A complement intersection B complement will be the region 4, comparing this outside A union B. You can see that this region that is shaded here represents the region that is what? Unshaded here. You can see this place that is not shaded. If I were to clean the shaded part and turn it over, this portion will have been the same as this. So we call this De Morgan law. De Morgan's law also say that if you have the complement of a union of a set, that is A union B complement, the complement of a union of a set is the same as the complement of the intersection, or the intersection of the complement. I think we put it that way. The intersection of the complement of the two sets, meaning A complement intersection B complement. It says that the union, the complement of the union, is the same as the intersection of the two sets, the complement of the two sets, as we have demonstrated here, that the union of this, which is the unshaded part, is the same as what? The shaded part here, which is the complement intersection. Alright, and that will also be true if this become A intersection B complement. That should also be equals to A complement union B what? Complement. These are the two laws under De Morgan's law. If I want to take this one, A intersection B, what is the A intersection B? I believe that to be region 1. A intersection B. So the complement will be outside it. So this is going to be the complement. The complement of what? A intersection what? B. So the unshaded part is the intersection. Now, let me also have the set A complement union B complement. Don't forget, if we are referring to A complement, we said it earlier on that A complement will be region 3 and 4. Region 3 and 4. Then B complement is going to be region 2 and 4. They say union. So putting together region 2, region 3, region 4. So region 2, we are putting region 2 along with region 3, along with what? Region 4. That is the union, putting them together, combining the two sets together. So you can see that the middle is unshaded, So this is also being true, that the complement of the intersection of two sets is equals to the union of the complement of the two sets. It's not only two sets. 3 sets, 4 sets, 5 sets. This rule or law apply to all of them. But I wonder if we are dealing with 2 subsets in this tutorial. The next tutorial will have to solve questions on data that lead to 2 set problem. Then we also try that on the representation on the 3 subsets, which will be the 3 sets. So this is what basically we have under the regions of what our 2 set problem or 2 subsets in the Venn diagram. The regions will be this. This will also be used in solving questions, as in whereby the set will be listed. Then if they give you a set A, let's say we have this set, just as we have described the regions. Then we are asked to represent this set on a Venn diagram. Meaning, when we have to indicate this set in the diagram. First of all, you have to first find the intersection, which is the region 1. Which element belong to both A and B? 1, no, 3, no, 5. So that will be represented in the region. That is the intersection. 7, no. So we have only 5 as the intersection of the 2 sets. Then you can represent the rest. So this is going to be 1, 3, 5, 7. This will be 2, 4, 5, 6. So if you are listing the set of B, 2, 4, 5, 6. If you are listing that of A, 1, 3, 5, 7. But don't forget, the universal set consists of 1 up to what? 8. So I will check and see whether all the elements are featured, or the members are featured. So 1, 2, 3, 4, 5, 6, 7, then you put your 8. So any other element that are not here will be placed here, region 4, which become A union B complement. This is A intersection B. This is what? A intersection B complement. This is B intersection A complement. Then it follows in that order. So these representations can be used to solve questions of this nature. I believe you have taken something out of this video. Yes, if you have, please, if you have not subscribed, subscribe to the channel to enjoy more of these videos. Like if you find it educative, share if you know somebody who may need this, and leave your comments below whereby we interact together. I learn from you, you learn from me. Thank you for watching. See you in the next episode.